Hey everyone, this presentation is on Chapter 14 of the DevOps Handbook on creating telemetry to enable seeing and solving problems. It was prepared and presented by Paul Meredith, Peter McAllister, and Spencer Olson. In this presentation, we'll be discussing best practices, creating a centralized telemetry infrastructure, application logging telemetry that helps production, using telemetry to guide problem solving, enabling production metrics as part of daily work, self-service access to telemetry of information, find and fill telemetry gaps, application, business, infrastructure metrics, and conclusion. Because problems are granted to occur, we want to ensure that we have the best practices in place to quickly solve and learn from those problems. In 2001, Microsoft's Operation Framework study found that those with a higher service level driving better performance actually experience fewer problems, such as 20 times fewer server reboots and 5 times fewer blue screens of death. This is because the high performers create a culture of casualty and use a disciplined approach to diagnosing and solving problems. They utilize animated communications or telemetry to monitor production along the valve stream. This helps them to quickly understand factors and focus on the roots that causes problems. In addition to Microsoft's findings, the 2015 State of DevOps saw the high performers will resolve instances up to 168 times faster than their peers, driving their faster mean time to repair 2 minutes rather than days. For Etsy, production monitoring began in 2009. They began changing their critical infrastructure due to different technologies that were being used across the company, which were becoming difficult to maintain. They adopted the LAMP stack, making Linux, MySQL, and PHP the standard tools for the company. Then they implemented telemetry to track everything. It started small but quickly grew. In 2011, they were tracking over 200,000 production metrics. They ensured that the top key metrics were displayed on their deploy dashboards, so they were kept visible. Within 3 more years, they increased their tracking over to 800,000 production metrics. An engineer at Etsy once said about telemetry, "If it moves, we track it. Sometimes we'll draw a graph of something that isn't moving yet, just in case it decides to make a run for it." To follow an example of Etsy, we first need to modernize our monitoring architecture. To do this, we first need to understand the system's behavior as a whole. We need to send all logs to centralized location. This allows for easier global access to what is happening. We also want to gather all existing businesses metrics to help us better understand how our system is operating. We then implement an event router which will collect, store, and summarize events and metrics given us telemetry. Once we have our production telemetry, we must collect the telemetry from the department pipeline. Deployment telemetry should shine light on important events which will go through automated tests resulting in a pass or fail. It should also tell us when we perform deployments to any environment. This will help us to know if it is taking longer for our builds and tests so we can fix the problems prior to production. Again, it is crucial that building telemetry becomes part of our engineers' daily work, not only in new but existing systems. As part of this daily work, we ensure that all application features are instrumented so that confirmation can be done to show that the application is being performed as planned. We want to create different logging levels which will help to identify certain triggers, such as debug level showing information on the programmer's activities, info level providing user-driven activities, a warning level shining a light on potential errors, an error level bringing focus onto specific areas with errors or features, and lastly, fatal level, which will tell us where we would need to terminate. To help confirm that all information we have is reliable, we ensure that all significant events will trigger a logging entry. As we stated, problems are guaranteed to happen, so it is important that when errors occur, that we avoid a culture of blame. Instead, we follow a specific method using telemetry to form a hypothesis. We start by identifying the evidence showing that there is an actual error. We then look for relevant event or changes that could be responsible or could have contributed to the problem. We form a hypothesis confirming a link between the proposed cause and effects. Lastly, we ask how we can prove that our hypothesis is accurate and how to successfully effect a fix. Fact based on problem solving rather than blaming others drives a faster MTTR and reinforces the win-win relationship within DevOps. As we strive to make the creation of our production metrics part of our daily work, it is important to make the process as easy as possible. We can do that by creating infrastructure and libraries that can be utilized by anyone along the value stream. In an ideal world, this would make it easy as writing one line of code in order to create a new metric that can be viewed by everyone. As we create our telemetry graphs, it is important to overlay them with production activities such as code deployments, maintenance windows, backups, and identify correlations. You can see how this would look on the image to the right there. The telemetry is represented by the blue and black lines showing the number of successive failed logins. The vertical lines represent production deployments. Excuse me. It is important that once we have our telemetry, we radiate the information to the rest of the organization. It must be made fast, easy, and centralized. This shows that the team has nothing to hide from visitors or itself. While it is optional if we broadcast our telemetry to external customers, it is important to keep in mind that by doing so, it would demonstrate transparency and potentially earn stronger trust from the customer. LinkedIn is a good example of how radiating telemetry can be beneficial to your company. The goal of LinkedIn was to make sure that users had continuous access and ensuring the site was up at all times. This would require that they were able to detect and then respond to failures as they occurred. One of the main struggles was their metric collector system made it difficult to dig through the amount of data that they had. To make this easier, they created a program called InGraphics, which allowed them to make sure the telemetry faster and easier. As a result, InGraphics has become one of the most visible parts of their operation. Excuse me. Being prominent blatantly featured in engineering offices where it would be hard to miss by visitors. Now that the infrastructure has been established to create telemetry, we now need to identify telemetry gaps. To do that, we need to enable our engineers to gather all needed metrics. In order to do this, we need to create telemetry metrics at all levels, business level where our sales, revenue, and signups to take place. Application level monitoring our transaction and response times, as well as our application faults. Infrastructure level, which is our databases and operating systems, network and storage take place. Client software level, this would be things like JavaScript on the client browser or mobile applications. Deployment pipeline level, which includes our build status, lead times, deployment frequency, test, and environment status. When looking at our application, business, and infrastructure metrics, it is important to not only create telemetry to enforce the health of the application, but to also drive towards our goals. Every business metric must be actionable. What do we learn from our telemetry so that we can make changes for the better? We then instrument user actions that will lead to our desired outcomes. In conclusion, we looked at examples of Etsy and LinkedIn. These examples revealed the critical nature of finding problems as they occur and the tools that allow us to do so. We covered the importance of having elements telemetry, which enables us to find and fix issues before they become catastrophe. Include database and environment. Thank you.